We're going to trace through another example of creating a 2-3 tree and a 2-4 tree. So beginning with a 2-3 tree, remember that the process is we search for the leaf of where the new element would go, and we want to add in that position, just like we would do for a regular binary search tree. However, we never add a new leaf. So balanced trees, in this case 2-3 trees, are very different. What we want to do is we want to add to the existing leaf where that value belongs, and then do whatever we need to do afterwards if that node is no longer valid. So if the leaf we're trying to add to is a 2 node, remember that means it has just one value in it, we just put the value there, which will convert from a 2 to a 3 node. If the leaf we're trying to add at is already a 3 node, what we can do is we can sort of pretend to add it there. That creates an illegal 4 node, and then that's when we split. In the splitting process, we split the left and right values into individual 2 nodes, so nodes with one value, and then we bump that middle value up to the parent. If that parent was previously a 2 node, it's now a 3 node and we're done. If that parent was already a 3 node, we need to split again because we've created an illegal 4 node, so we repeat that process. So let's again walk through another example. So these are the values we are going to use to build our 2-3 tree. So we start with just adding the 6, and this is of course a valid 2-3 tree. Next up, we're going to add the 4. So the 4, we want to think about it as here, right? So this is what we would do if this was just a regular binary search tree, but of course it's not. It's a 2-3 tree. So we're going to find the leaf where the 4 belongs. 4 is less than 6, so we want to add the 4 into the 6 node, making this now a 3 node. Sorry about that. I forgot to make these ovals so that we could make them a little larger so that we can tell that it's a 3 node. So remember that a 3 node has 2 values in it, and it's called a 3 node because it could potentially have 3 child nodes. So right now this is our valid 2-3 tree. Next up, we're ready to add the 7. So the 7, we hit a leaf and we want to put it to the right of 6. Right? That's where we want our 7 to go. That's where it belongs. We don't add a new leaf, right? So we wouldn't put a right leaf off to the side of the 6. That's not how we build a 2-3 tree. We don't ever add a new leaf. We just add to the current leaf that's already there. Okay? Now, in doing this, I have created an illegal 4 node. A 4 node is a node with 3 values, and I can't have that in a 2-3 tree. So I need to do a split. So how that works is I bump the 6 up a level, which in this case is just going to become the new root. And let's do it this way actually. Then make the left and right child. Be 2 nodes, and now this is my valid 2-3 tree. Okay, so it's a binary search tree. Everything to the left of the 6 is smaller, everything to the right of the 6 is greater, and this is a valid structure for a 2-3 tree. Okay, now next up I'm adding the 9. So I come over to the 9, 9 is greater than 6, so I go to the right and I've hit a leaf. So this is where I need to add my 9. Now again, I don't add a new leaf. What I do is I add the 9 to the existing leaf. Which creates a 3 node. Okay, so this is my 2-3 tree so far. Again, you can confirm that it has all the properties of a 2-3 tree. Next up, we want to add the 8. So 8 is greater than 6, so I'm going to go to the right, and I found the leaf node where it belongs. Now, again, I don't add a new node, a new leaf rather, but what I do is I kind of make, again, this illegal 4 node. This is where I want the 8, but I can't put it there because I can't have a 4 node in my tree. So what I'm going to do, and hang on, I'm just going to make a copy of this for a moment because I want to come back to it a little bit later. What I am going to do is do my split. So to do my split, I take the middle value, the middle value of this 4 node, and I bump it up a level. I bump it up a level to the 6. The 6 now is just a 2 node, so now the 6 is going to become a 3 node. And this, the 7 and the 9, now split into just regular 2 nodes. So this is what my tree looks like at this point. Now you can see again that this is a valid 2-3 tree. So everything less than a 6 is in the left, everything between a 6 and 8 is in the middle, and everything greater than the 8 is over on the right. Okay, and it has our structures of just having 2 nodes and 3 nodes. All right, so next up I want to add the 2. 2 is smaller than 6, so I go to the left and I find a leaf, so I'm going to add the 2 there. And that's just a 2 node, so I turn it into a 3 node and I'm good there. Next up I want to add the 5. The 5 is less than the 6, so I go to the left and that's the leaf where it needs to go. So again, I pretend to add it there, but now again I've created an illegal 4 node, so I have to do a split. So to do a split, I take my middle value and I bump it up here. Now I've made again an illegal 4 node, but let's ignore that for just a moment and let's finish the current split we're working on. So for the current split I'm working on, I need to take the left and the right child and make them 2 nodes. Now, this would be a valid structure, right? The 2 is less than the 4, the 5 is in between the 4 and the 6, the 7 is in between the 6 and the 8, and the 9 is off to the right. But, of course, we can't have a 4 node in a 2-3 tree, so we have to do a split again. So for the split this time, I take my 6 and bump it up. There, of course, is no layer up, so I need to just, create another layer. It's going to now, again, be the root. Then I take my 4 and my 8, and I make them 2 nodes, linking them up this way. So they go with the new root that I created, and then all my other 2 nodes get linked up there to that new level. And you can see that again, we've got our properties of a binary search tree. So everything to the left of the 6 is less than the 6, everything to the left of the 4 is less than the 4, everything to the right of the 4 is greater than the 4. Everything to the right of the 6 is greater than the 6, everything to the left of the 8 is less than 8, everything to the right of the 8 is greater than 8. Okay, so this is what the tree looks like so far. Last value to add is my 3. So when searching for the 3, it's less than 6, so I go left. It's less than 4, so I go left. I hit the 2, and that is a 2 node, so I just add it into that leaf position. And that is where my final leaf would go. So that's what my final tree would look like. Okay, so there's an example of building the 2-3 tree. Now I want to return for a moment to what it looked like when we had this tree here and we were ready to do our split. So this was when we added the 8 to create this illegal 4 node. Okay, now the common mistake I see, and I showed you this earlier too, and I'm hesitant to show you because I don't like showing mistakes, but it is a common one, so I just want to walk through it one more time, is during this split, the common mistake I see is that the split is done this way. So just by converting the 8 into a 2 node and then putting the left and right children down below it. Now what makes this extra tricky is that this is a valid binary search tree, right? It still has the properties of a binary search tree, but the problem is it's not balanced anymore. And remember, that's the whole reason we're doing this, is to keep these trees in balance, right? So the idea is that if we were to split this way and we were to continue adding to that tree, right? So let's add, let's add a 10. Okay, so we'll add a 10. Oops. So the 10 is bigger than the 6, bigger than the 8. We'd come over here, make that a 3 node. Now let's add an 11. 11's bigger than the 6, bigger than the 8. So here I'd want to add another value here. But of course that creates an illegal 4 node, so I need to do a split. If I were to do a split in this incorrect way, again what I'd be doing is I'd be splitting into 3 2 nodes. Right, so 3 just kind of regular nodes, making this the 10, and then linking up. Now again, this does have the valid properties of a binary search tree, but you can already see how this is very much growing in balance. Out of balance, right? It's growing imbalanced, I should say. So it's going to be very heavily skewed in that direction. So look for, right now, just with adding those 2 values, the 10 and the 11, we have a tree of height 1, 2, 3, 4. So we have a tree of height 4. Let's go back to our tree that had it done the right way, and let's add the 10 and the 11. And of course, I left off the left-hand side for the bottom tree, but that doesn't really matter. So adding a 10, 10 is bigger than the 6, I go right. 10 is bigger than the 8, I go right. I add here at the leaf, creating a 3 node, that's allowed. Now I try to add 11. 11 is greater than the 6, I go right. Greater than the 8, I go right. I want to put it to the right of 10. But of course, this creates my illegal 4 node, so I'm going to do my split, and I'm going to split the correct way. So I'm going to take my 10 and bump it up to the level above. The level above is currently a 2 node, so it'll just turn into a 3 node. That's allowed. And then my 9 and my 11 will just get converted back to 2 nodes and linked up this way. And you can see this is still a binary search tree, right? The 7 is smaller than the 8, the 9 is in between, and the 11 is greater than the 10. And this has only a level, a height of 3. It's much more balanced, right? So you can see there's a difference there already, and as you add more and more nodes, the difference is going to be even more extreme. Okay, so if you do that incorrect splitting process, you're going to get a very unbalanced tree, which is the whole purpose of doing these trees, is to create a tree that's in balance. So you want to make sure when you're splitting that you take that middle value and you move it to a node up above. You don't kind of create a new level and push things down. You always think about kind of pushing things up, right? So take that middle value, bump it up. And if that bumping up creates another illegal node, then you got to do another round of splitting. But you never want to kind of say, okay, I'm going to take that middle value, leave it here, and then split off kind of down below, because that's where you'll get that imbalance. So make sure that splitting process makes sense. That's really at the key of what allows a 2-3 tree to be balanced.